Thank you so much. What a beautiful venue. I am so impressed to be here with this beautiful setup. And I live in Southern California, so almost Mexico anyway. But yes, this week I had the best tacos I've ever had in my life. And Mexican food is the food of Southern California too. But that's not my briefing. So we at Galorath are the people that developed the SEER models for cost, schedule, risk, and reliability estimation. I'm not going to talk about the models today, but I'm going to talk about some of the things and challenges in estimating that we've been faced with and that we've dealt with at Galorath. So about a year ago, we had an organization came to us and said, hey, we are going to go to the cloud, and we are going to try to use open source software. They said, as an organization, we've never done this before. Can you give us some guidance on how to do this and how to cost it? So we looked at modernization. How do you modernize software and put it on the cloud? And what about open source software? This particular organization had never used open source software before. And they were trying to figure out how to use it, how to get value out of it. Now, the big three key points are that modernization can be costly, but it's often worth doing versus starting all over again on a large system. And this was an extremely large system. Open source software, which they thought was free, isn't really free. I'll talk about some of the costs in a minute. And open source, agile, cloud, and other technologies can help, but again, none of these things are free. The world, at least the United States, the people are looking for free software. Everybody wants it to be free because it's cost so much over time. There's no free software. You might get the license for free, but we're going to talk about some of the costs. Next, please. Now, I believe when we're looking at software costs, why do we do software estimation? And here we've got a whole group of people to do software estimation. We do it, hopefully, to provide value to the business. So as I look at this, we've got IT services, IT infrastructure, software development, software maintenance. All those need to be weighed against the value to the business in terms of return on investment and those kind of things. Sometimes we just do a software project for the sake of doing a software project. Many times we do it or should be doing it so that we can figure out how it's going to save money for the business. Next, please. Now, if you look at the alternatives for modernization, the first one is retire. Throw it away, start over again. Next one is refactor. Go into existing software and try to make it easier to use. The next one, replace. Take the existing software and buy an off-the-shelf product. Next one is retain it and wrap it. Keep it as it is, but build software interfaces around it that work in a more modern way. So it might be a modern user interface or something, still using the old code. Next one is rehost. Take the existing software, which might be on an older machine, and move it to a newer machine. And last one, redevelop. Start all over again. These are basically the R's, the different ways. I guess they're the R's in English. I'm not sure the R's in Espanol, but that was supposed to be funny. Thank you. If you don't laugh, I'm going to feel bad. So, all right. So here's the alternatives. What do? Throw it away, fix it, deal with it, redevelop it. Next slide, please. Now, when modernizing, first you need an as-is model, figuring out what the system does now so you can figure out what it is you're modernizing. That might seem like an obvious thing, but there's huge cost potentially in that, and that is systems engineering. We are seeing the costs of systems engineering, both in software and in systems, going up dramatically. So if you're just estimating the developers, you might be missing major portions of the cost. Next, please. That should have painted in two pieces, but the first one on the bottom is the things involved in software. Requirements, design, implementation, tests, you all know these. That's the blue things. But if you look at the work involved in an IT system today, one is being modernized or another one, all the yellow things need to be estimated too. How much is the help desk going to cost? What about backup and restore? What about deployment? And on and on and on. One of my kids got an internship with Deloitte, the consulting firm this year. And he saw me working on a slide. And he said, Dad, he said, that slide's overwhelming. And I said, yeah, Steve, that's the point. And so his free advice from Deloitte was make it simpler. The point is, there's lots of stuff to estimate here. And if we just estimate the cost of the software, we will be in trouble because we're going to miss huge parts of the cost. Next, please. Now, if you look at typically the costs, software development is usually about 6 to 10% of the total ownership costs of a system. 6 to 10%. We've got IT infrastructure, IT services are generally 60% or more of the cost. And then, of course, software maintenance is a huge part of the cost. So if people just, one of the areas, the Agile, how many of you are Agile lovers? Agile? Good. I love Agile too. But here's some of the things that are often forgotten. We're going to just build it. We don't need estimates, right? Because it's Agile. We're just going to go till it's all done. And I do believe we need estimates, by the way. But then they don't consider what's the total ownership costs. What is going to happen if this software was built without significant documentation because we're Agile and it's going to have to run for 10 years? How are we going to maintain it? So this isn't a presentation on Agile, but Agile software needs estimates too. Next, please. If you look again, this is just showing the left-hand blue is the cost of development. The right-hand pieces are the various costs of maintenance, depending on how rigorous the maintenance is. Maintenance is a fascinating thing. We've collected maintenance data for years. In fact, we, Galorath, have the largest maintenance database in the world, I believe. The U.S. government has provided us a database along with a number of other people that we've collected data from. And here's the bottom line of maintenance. Maintenance is a level of effort activity. That means if you say, for example, our SEER model might say you need 12 people to maintain this. The project manager might say, hey, we're only putting 2 on, deal with it. Well, okay, put 2 on. What happens though, the cost goes down of maintenance, the technical debt goes up. And in fact, in many cases, the software ends up being obsolete and you have to throw it away and do it over again, back to the modernization, because they didn't spend the time appropriately on maintenance. Next slide, please. Let's talk about open source now. Next. Open source software. Free, everybody thinks it's free, and sometimes it is. And the license is free, but just using software that's, quote, free doesn't solve most of the problem. You still got to test the system. That is, I'm referring now to components, to off-the-shelf components. You've still got to test the system. You've got to do the systems engineering. Once again, systems engineering costs are going through the roof. So there's really 4 different kinds of open source software the way we look at it. There's open use, means you can go download it, you can GitHub or wherever, you can do whatever you want with it. Black box use, where for example you go to, you get software Linux and you don't get the source code, but you get the executable system and use it. Right? Black box from a vendor, and this is probably the most popular version of open source today, where you don't go and just do it yourself. Because if once you own it, once you change it, you've got to maintain it yourself. But go to a vendor. For example, Red Hat for Linux. For example, my company uses a VoIP phone system it's called Digium. That took an open source version of a product called Asterisk and productized it. And then the last one is open use. Take open use developmental. You take it and you say, we're just going to start with this. We're going to change it all around. Next. Now here's where it gets complicated. The licensing. Public domain, open source software, do anything you want with it. Doesn't mean it's safe, doesn't mean it works well, but you can do anything you want. You can use the source code, you can use the executable code, anything you want. Permissive says that you've got minimal rights to modify the software with some requirement to have it redistributed. Lesser general public license, any user is given the right to modify, but any code that you work with might be exposed to somebody else. By the way, once you modify it, that doesn't mean that the open source version is going to use it, so you've now got it and you own it yourself. Copy left. Now this is, in English, copyright is the way we use probably a copyright Galorath 2018 on the slide. Copy left is an open source thing. It says instead of a copyright, anything you do has got to be distributed to everybody all the time. Well, let's suppose you're in a bank and you're doing significant banking analysis and banking software. And and you decide, and let's suppose you're doing the security part. If you're using copyleft, you've got to give all the code that you've written out to the industry. May not be very safe. And of course, proprietary software, all the rights are reserved, just like Windows or whatever. Next, please. Now, in the U.S., the U.S. government, is this being recorded? Okay, I'm not going to say it then. Okay. By the way, I apologize for this nonsense on the wall, too. Nobody wants the wall. No human being in the United States wants a stupid wall. But I guess that was recorded, too. In any case, so the Office of Management and Budget in the United States Government Office said, hey, we're going to save a lot of money on software. We're going to make all of it be 20% reusable or open source. So if you're building a product and you're required then to donate 20% of it as open source into a repository so other government organizations can use it. Well, you know, it kind of sounds like a good idea in some ways. I suppose we could do the same thing with English or Spanish prose. We could take some paragraphs of a document we made and donate them to the world, and somebody else maybe can use them someday. Well, here's the problem. They probably don't have the right function. They probably haven't been appropriately tested, and they're probably not designed to be open source or reused. If you look at the graph on the right, it shows the additional costs of ensuring that software is reusable, generically reusable, not just reused and it might work and it might not. And that's about 63% more cost to make sure the software is generically reusable in the first place. That came from our SEER model. So they're going to have a repository with all this stuff, open source, that other people could use, but nobody will probably use it because you don't know what it is, you don't know how well it works, you don't know if it's been tested, you don't know anything about it. So just saying it's going to be free isn't good enough. Next, please. Now, to estimate open source costs, once again, you need the systems engineering work. What is it we've got to do? What's the requirement? What's the repository? What kind of open source might be safe? Estimate the open source development costs, whether you're just using it or whether you're modifying it or whatever. Followed by C, estimate the maintenance and obsolescence costs. We'll talk about obsolescence in a minute. And last, estimate the operational open source license costs. These can be huge. If you're using a vendor-provided open source, the licensing costs could be very large. By the way, I don't know if, I assume this will be posted on the web with the association. I also posted it on our website if you want, Galorath.com, and you can find these slides if you'd like. Next, please. So the 4 kinds of open source software. Open use. Anybody can do anything with it. Great. Pick it up, start using it or changing it. Hope it works. Test it, please. I always ask people, by the way, when they talk about open source or reused software, oh, we'll do this and it'll be cheap or free. I always say, suppose you were going to fly on an airplane and they'd use some open source software they found somewhere and they hadn't retested it. Would you be comfortable on the airplane? How many of you want to get an airplane with open source software nobody tested? Nobody. What if you had to go to Fiji? There you go. One will take it up for Fiji. So we need to know how reliable it is. We need to know what the licensing costs are. You know, again, licensing can be huge. Next, please. Now, there's lots of ways to look at open source software. First of all, if it's open source, that means the source code is available. If you're purchasing from a supplier, for example, Red Hat versus the you can do it yourself license, they might be slightly different, but you can run reliability analysis. You can get the number of lines of code. I know Harold doesn't like lines of code, but lines of code can be valuable in many places if you use them properly. If you just use them incorrectly, lines of code are garbage. If you use them appropriately and you with care, they can be very useful in many circumstances. We still love functional sizing, but I wouldn't throw lines of code under the bus. So you can run code analysis, find out how good the code is, find out how much code there is. You know, you can estimate with lines of code too. If you're going to change 30% of it, and you know it's 100,000 lines of code, you can do a pretty good estimate of how long it's going to take, how much it's going to cost. Next, please. Now, there's a database called Coventry. They were just acquired by a bigger company, so they might have changed the name. but they have collected defect data and size data for over 700, I think there's almost 800 projects now. If you're looking to use some open source software, if you go to the Coventry database, you might find its defects and you might find its size in lines of code already available for you. And next, please. You can compute the effective size. I realize this is too small to read, but what this is basically showing, for open source or for any other software really, you can figure out what the work is going to be compared to new by looking at how much is redesigned, how much is re-implemented, and how much is retested. And again, it's in the slides. It'll be on my website and the organization's website as well. But using these factors, we can say, for example, how much are we going to have to reverse engineer? Figure out what this open source software does before we start doing anything with it. Well, we probably should know what it does before we start using it. And those can be significant costs. Next, please. Now, the next issue is obsolescence risk. If you choose open source software or other commercial off-the-shelf software, you can end up with, and you should plan for, obsolescence. That is, one day, if this system's running for a long time, if we've got a system with a 10 or 20-year life cycle, the one we were contracted with on the study had like a 20-year life cycle, how much of the open source software that they're depending on being maintained will still be around? Did anybody here ever use OpenOffice? It was the free version of competitor to Microsoft Office. Anybody? Yeah, several of you. Well, OpenOffice was a good thing, I guess. We're Microsoft partners, so we got free copies of Office. So we didn't need that. That was supposed to be funny again. Here's what I'll do. If I'm trying to make a joke, I'll go like this, and then everybody can laugh, okay? All right. So all kinds of politics happened, and the developers said, we're not going to work on OpenOffice anymore. I believe OpenOffice was at some point acquired by Sun Microsystems, and then Oracle. And so developers said, we're not doing it anymore. We're going to move to LibreOffice. And they did another version of Office. Well, anybody stuck on OpenOffice was out of luck. And this happens in OpenOffice, no big deal. You go by Microsoft Office or you can use other things. This happens on graphics packages. My own company used an open source package for graphics some years ago. It worked pretty well. And then over time, the developer community stopped supporting it. We had to change graphics packages. Now, that was not a significant thing. So had we done a plan for total ownership costs, we would have had the probability and risk of having to redo something because the open source no longer supports it. Or you can support it yourself, and now you've taken on a huge, huge problem. So if you look at the steps, and how much time have I? Is anybody timing me? All right, I'm just going to keep 10 minutes, good. If you look, I'm going to talk faster then. I know Spanish people talk faster than Americans, so we should be good. All right, we're doing open source software. First, once again, systems engineering costs, selection costs. These are extremely expensive, or can be extremely expensive. Don't misestimate by not including those. COTS cognition, that is comprehending what the open source software does so you can use it, a big cost. Integration and test, obviously, yes, we know how to estimate test. Maintenance, data migration, these are all things that can be costs, even if it's open source. Once again, open source isn't free. Next slide, please. Let's talk about cloud now. Now, this is a big organization. Not only are they going to put it on the cloud, they're going to have the cloud supplier build a special cloud facility just for them. So, big cost. First of all, if you look at NIST, they talk about 3 levels of cloud. There's infrastructure as a service, platform as a service, and software as a service. We've seen in the world infrastructure and platform kind of melting together, and in some ways software as a service melting together as well. There was a time these could be the cost drivers, not anymore. Next. We basically know how to estimate cloud systems, right? Once again, systems engineering costs can skyrocket versus doing things in-house. People say, oh, we're going to save all this money because we're going to get rid of all these people, right? We're going to get rid of all these people that are backing up our IT systems and things. That's great. Many jobs change. Most don't disappear. Now, again, I'm not saying cloud's a bad thing. It's a good thing in many ways. But once again, if you're estimating the costs of cloud, and how many of you do this? You're mostly software, or you do whole IT systems? How many do cloud estimates? How many are going to do cloud estimates? All right. Things like bandwidth. Suddenly everybody's on the cloud. The whole organization needs 1,000 times more bandwidth out to the cloud. Risk has got to be factored in. Data accessibility. Cloud can be more secure now than on premises in many cases. But some people think cloud is a panacea. We're going to solve all our problems, solve all our costs. Certainly going to lower your electric bill. But cloud, again, is not necessarily cheaper. Next slide, please. This is an example of going to Dell and buying a server, plopping it in your own facility. Doesn't include the power and the space. But over 5 years, this particular example was $8,800. The equivalent cloud functionality over 5 years was $32,115 for the same amount of functionality. They say, how can it be so different? Well, remember, cloud, and by the way, prices are dropping regularly on cloud, so this number could go down dramatically as well. But with cloud, you're leasing it instead of buying it, right? You've got to pay the lease every year. The costs go up potentially, or maybe they go down. But just because it's on the cloud is not necessarily cheaper. And this is just infrastructure. Again, it's more convenient. You don't have to have power, space, weight constraints. You don't have to have the IT people in there to do the magic of backing it up and things. But it's not dollar cheaper, dollar per dollar. Plus people think, oh, well, all of our IT people will go away. No, you still need the help desk. You still need this and that. Next slide, please. This is an eye chart. The bottom line of this slide is that the things in red are things that the corporation must take control of on a system. Is infrastructure, all you get is an operating system and hardware, basically. Everything else is your problem. And by the way, service level agreement, you can't always guarantee uptime on the cloud as well as you can on your own systems. And you can see platform and software as a service, it gets less red, less things you've got to do, but it's still a lot of work. Next slide. Well, that's an eye chart even for me. This is great. By the way, I thought Harold was up here doing this all from his head. I was so impressed that I found out just a big monitor here. So again, cloud selection and costing, systems engineering. Are you all estimating the systems engineering work involved in your products? If you're not, you probably should start if you're doing substantial systems. The migration costs. If you're moving, for example, onto a cloud system and you're trying, oh, there's 10. Was that my presentation style or my suit that was rated to 10? Okay, come on, that was a little funny. Thank you. I have many friends from Mexico. I know they laugh at my jokes. Maybe only politely. My actual software development costs of putting it on the cloud. Hopefully there's no cost. Hopefully you just get a virtual machine and toss it up there. But in many cases, you might be refactoring, reworking it, and there's substantial software development costs. And then supplier costs. You can go to the Amazon website and you can find out how much a virtual machine will cost, their storage or bandwidth and things. But that's only the tip of the iceberg. Those costs often double or quadruple because you need hot backups, you need different things. And you still need the people the systems engineering to do that work. Next, please. All it's saying is, just because you can go on Amazon and get a quote, it doesn't mean that quote is right. Look at the labor, look at the design. Will it really work? We just had a thing the other day. One of our people wanted to use something on Amazon. And they said, oh, Dan, it's only $6.19 an hour. Well, that sounds pretty good, right? But that was every hour for the year. That was $54,000 a year. Now, Amazon was pretty bright talking about $6.19 an hour, but $54,000 a year, whole different story. Next, please. Cybersecurity. 3 basic things in cybersecurity. If you're worried about, and I assume some of you are banks and insurance companies and other government organizations, there's three different dimensions. First is hardening of the cyber products. That is, making the software secure and the hardware secure. The more you can do with hardware, the better off you are. It can be 400% more expensive to make your software generically secure, 100% secure, well, 99% secure, than to do it with hardware. Hardening of IT or cloud networks. going in. This is where Amazon and Azure and those guys are really doing a good job now, because they're providing that security better in many cases than we can do on premises. And then cyber-related policies and practices. The biggest thing today is phishing. We use Microsoft's Cloud Mail. Again, we get it free because we're Microsoft partners. And I must get 20 messages a day, 20 phishing messages a day. I don't know why they're not catching these things. And some of them are really good. Next, please. That's an example of a work breakdown structure I'm sure you can't read. It shows the costs of a cloud. This was a intrusion prevention system, and this is in our SEER model. Shows both the IT infrastructure, IT services, and software costs involved in estimating a cybersecurity model. I'm sorry, a cybersecurity cloud software model. Next, please. I realize you can't read this one either. We have spent the last 3 years collecting data on cybersecurity. And I think we've got the largest database in the world on the cost of cybersecurity items, both the cost of the products and the services to go along with them. We think this is extremely important and continually more important. We're going to be doing papers and talks and publishing things on our website about cybersecurity costs in different ways. Watch the website if you want. Next, please. So the 3 points. Modernization can be risky, substantially miss or underestimated. Be careful. By the way, you need to include risk in your estimates. Modernization approaches can reduce cost and risk, but the systems engineering work has got to be appropriate to make sure you're doing the right things. And things like open source, agile, cloud, and technologies can help, but none of them are free. They all come at a significant cost. Next slide. So there's my contact information. Like I said, El Segundo Boulevard, I guess we're in El Segundo Boulevard means the second in Spanish. We're almost to Mexico. Feel free to contact us anytime. Okay, then, well, I thank you very much.